So I think we are good to go. And again, a warm welcome to everyone. And thank you for joining us today. My name is Rafaela. And before we start this session, I would like to just remind you that your phone line is muted. However, you can communicate to us through the chat or the Q&A. Please use the chat only in case you are facing any technical issue. So to request assistance, because your message will be visible to the host only, so myself. For any content-related questions or comments, use instead the Q&A. You will find it clicking the Q&A icon you see at the top right corner of the WebEx page. The panel will open, write your message there, and direct it to all participants. Finally, I let you all know that this session will be recorded. The first presenter that we have here today is Irene. Irene, over to you.
Thank you, Rafaela. Good morning, everyone. My name is Irene Camino. I work at Everest, and I am the project coordinator of AMU-LED. On behalf of the AMU-LED Consortium, I would like to thank you all for attending today our first workshop, discussing the future of UAM operations. In this workshop, we would like to introduce our project, in particular the main goals and scope of AMU-LED. Afterwards, we will present the use cases that we have defined so far and the details of the demonstrations. The high-level concept of operations proposed by AMU-LED will also be presented, being the objective of this workshop to receive your valuable feedback to incorporate it in a following version that will set the basis for the AMU-LED use cases and the flight demonstrations. At the end of the workshop, we will have the opportunity to openly discuss the CONOPS and answer the questions that you may have. AMU-LED is a very large demonstration project funded by the SESARJU joint undertaking, and we had our kickoff meeting on January 21st this year. AMU-LED, which stands for Air Mobility Urban Large Experimental Demonstrations, is an ambitious initiative that will be developed during 2 years, and it will tackle all issues related to urban air mobility, providing important leverage for all the technologies involved. The consortium is composed of 17 partners. The major players in UTM and urban air mobility have joined. They include relevant stakeholders covering the whole spectrum: industry, authorities, universities, and technological centers. The ultimate goal of our project is to demonstrate the safe integration of all types of drone operations in urban environments. The whole environment will need to be integrated safely with manned aviation and air traffic control. In order to achieve such challenges, we will define, implement, and deploy following the work package structure depicted on the right. Our project is composed of 8 work packages, as you can see. The work package 1 is the project management, monitoring, and ethics, and it will oversight the whole execution of the project. Once the definition of the high-level concept of operations is performed in the work package 2, the potential use cases are characterized in work package 3. Examples of use cases are air taxi operations, cargo transport, delivery of goods and medical equipment, or police surveillance, among others. We are currently at this point. Next, the work package 4 implements the technical solution so that, along with the use-based architecture, integration and deployment of aerial systems can occur in work package 5. The flight test campaigns are handled then within work package 6, which has the largest effort of all work packages, as you can see. The results, together with the outcomes of work package 2, are then fed to work package 7, which is the support to standardization and regulation. One of the key activities is the dissemination and communication of the advances and findings of the project, which is organized within work package 8. Moving on the demonstrations, the flight test campaigns will accumulate more than 100 hours of flights. They are scheduled in 3 different locations and will be managed by different partners. The demonstrations are organized in such a way that the complexity is increasing as they take place. And so the first one, which will be in the UK, in Cranfield, takes place in a fully controlled environment. The one in Randstad in the Netherlands will involve more factors, different UAM issues. And the one in Spain, in Santiago de Compostela, is planned to be performed near the airport, which is therefore more complex. There will be 2 air taxi providers, IHAN and Tecnalia, flying the 3 locations, and also autonomous and conventional UAS. Fixed wings and multicopters are expected to fly too. The 3 demonstrations are scheduled for the summer of 2022. We seek to get more impact of our activities and reach more public through our website and our social media accounts that you can already visit and follow if in case you like them. We plan on participating in different conferences and journals, but I would like to highlight the significance of our first press release announcing the kickoff of AMU-LED that got over 80 publications in the main newspapers all over Europe. One of the key components of this project is the advisory board, which at the moment consists of 30 members. That is amazing. We count on them, on you, to reach our objectives, and we expect your support in the different workshops that we will organize throughout the project. Although the dates need still to be defined, we will organize our second workshop before the demonstrations to explain our demo plan, and the last workshop will show the results of these flights. We plan on involving the advisory board also in the different questionnaires that we are preparing to incorporate your feedback to our advances. Finally, you will also be kindly invited to attend the demos. But first, we need to keep working in the project. To show you our first findings, I will give the floor to Marta Tojal.
Thank you, Irene. Hello, everyone. I am Marta Tojal from NLR, and right now we're going into the second item in our agenda, which is the use cases and flight demonstrations overview. So, like I said, hi again, Marta Tojal. I'm the leader of the demonstrations in AMU-LED. And so I'm just going to give you a quick overview of the demonstrations that are going to take place within our project. And like Irene said, we have the flight campaigns are going to take place in 3 different locations. So we have the UK, Spain, and the Netherlands, and we're going to make use of different locations and different testing environments so that we can test all of our objectives in the project. So the first flight campaign, I will go quickly through this because it's already been explained by Irene. So the first flight campaign is going to take place in the UK, in the Cranfield University Global Research Airport, and this is going to take place in June of 2022. Second flight campaign is going to be in the Netherlands, and we're going to make use of 3 locations. That's going to be the first one, Enschede, second one, Amsterdam, and the third one in Rotterdam. And that's going to happen in August of 2022. And 1 month after, the final demonstration will take place in Santiago de Compostela in Spain in September. So what are we actually going to demonstrate in the flight campaigns? So AMU-LED follows an objective-based approach, meaning that we have these 2 top-level objectives, which are the safe interaction of UAM with other users and safe UAM flight, that these 2 top-level objectives are going to dictate what we're going to test in the different flight campaigns. And the way that we're going to do it is that we will derive these 2 objectives into sub-objectives that are more detailed and measurable so that we can create scenarios that are also linked to the different objectives and to the use cases, creating a holistic story that we can tell and demonstrate in these 3 different countries. And the kind of things that we're going to demonstrate in the locations are, for instance, the different use space services described by Chorus, so U1, U2, U3, and also U4 services. We will test and demonstrate the capabilities of U-Space to deal with typical UAM challenges, such as loss of communication, the confliction between drones, BVLOS operations, and also issues like urban canyoning and others. Um, we will also demonstrate safe integration of UEM with other airspace users through U-Space capabilities. We will test and optimize the airspace classification management, and we will also define and test two different architectures in the different locations. So we're going to test a centralized architecture and a decentralized architecture in the different flight campaigns. And in the end, the demonstrations we will have in the demonstrations we will have different flights performing different missions with different use cases, and hopefully this will allow us to um, take a step into the future and demonstrate what we want to do and go one step farther with U-Space. So as I said, the first location for the campaigns is Cranfield. And Cranfield is actually the only university in Europe that has their own airport, their own ANSP tower pilots aircraft. So they have this sandbox-like environment, which of course we're going to take to our advantage, and we're going to use it to test the new concepts that we are developing within AMU-LED. And the platforms that we're going to fly in the campaigns in the campaign in Cranfield are the EHAN. So we have two different UAM vehicles, manned and unmanned. We have the EHAN and we have the Tegnalia, and we'll also be flying different autonomous drones from Cranfield University. And with all of these flights and all of these tests, what we want to demonstrate are ATM and UTM integration, simultaneous operations of two different USSPs given services to two different drones, the different architectures, both decentralized and decentralized. And this is something that we can do also thanks um, to the simulating environment that we have in Cranfield. So in Cranfield, we will not only have the real flights, but we'll also have simulated flights thanks to their ATM simulator, which will be providing a synthetic simulating environment, and we'll have virtual flying elements, including signals emulation of flying vehicles into the demonstration. And we will also be utilizing the different U-Space services, so the U1, U2, and U3, but we will also test the challenges that we still have to overcome to implement U4 services. We'll also be flying VVLOS operations in Cranfield, and we will test emergency operations and landing as part of contingency management and the confliction between manned and unmanned urban air mobility vehicles. Um, the second flight campaign, it's in the Netherlands. And like I said before, we will have three different locations in the Netherlands, Enschede, Amsterdam, and Rotterdam. And here we also follow a progressive approach, meaning that we'll start the first test in Enschede and we will build it up towards Amsterdam, validating the scenarios that we had in Enschede in this second location. And we will end up in Rotterdam with a final proof of concept of the demonstrations in the Netherlands. And the main locations that we're going to use in the Netherlands are the Space 53 site in Enschede. Space 53 is one of our partners in the project, and we will probably be flying from that site, which is next to the Twente airport, towards the center of the city, flying towards the medical centrum in Enschede. Then in Amsterdam, we have two possible sites. One is in the Amsterdam side of NLR. We will be making use of our drone port initiative to do some tests. And this is a very interesting environment because we're not only within the CTR for Schiphol, which is one of the most busy airports in Europe, but also we are embedded in the business quarter of Amsterdam and also next to a lot of resident buildings. So we have a lot of possibilities to test in here. And the other location is the Marina Terrein in Amsterdam, which is right in the middle of the city. So it cannot be more centric at all. You have boats in there, you have water, you have people, tourists, everything. So it's a very interesting environment um, to create a demonstration in there. And finally, in Rotterdam, we will be flying in the harbor and in the airport, and parts of the flight will also be within the CTR of Schiphol. And this is a very interesting environment as well because in the harbor is a very busy harbor. We have a lot of traffic in there, and we will be flying possibly towards from the harbor towards the airport. And we have also a lot of buildings and traffic and um, people to create a challenging environment from which we can demonstrate our objectives. And the platforms that we're going to fly in the Netherlands are the IHAN. We have also some drones from NLR. We have the autonomous drones from Cranfield, and we will also be flying with the trauma helicopter from ANWP. So what we're going to demonstrate through these flights and in these sites, it's a safe integration um, of manned aviation, and we'll also test engagement of drone versus drone, engagement of drone versus eVTOL, or drone versus the manned aviation, the helicopter, for instance. We'll also demonstrate safe prioritization procedures for medical drones. We will have a test for the operational procedures and mechanisms for having interface with ATC. We will have the confliction between two drones pre-flight and in-flight with U-space services. We will be flying above urban areas and above water, deploying the U1, U2, and U3 services, and we'll be performing the flights in liaison with an air traffic controller from a controlled airport. And finally, the last demonstration will take place in Santiago de Compostela in Spain. And this location is also embedded within the CTR of an airport, the Santiago de Compostela airport, which receives also regular flights every day. And the location for the demonstration is going to be in a suburban area within the city. So it's probably going to be class Z airspace. And the platforms that we're going to fly, we have the IHAN, we have the Tecnalia, and also different drone autonomous drones from Cranfield. And this demonstrator, it's going to be the evolution of the previous demonstrators to test the use-based architecture, the decentralized use-based architecture, which will be given a tracking service provided by a common service. And we will have the U1, U2, and U3 services as well, including basic dynamic capacity management. And this is going to be happening in a UAM scenario inside of the CTR of Santiago, where we'll have rich traffic, including the two eVTOL platforms, the one helicopter from the emergency services from the region. We will have two emergency response drones, one autonomous drone, and several other flights. So all of these flights are going to be flying different missions simultaneously and within the CTR of Santiago, which will allow us to test the interaction with ATC. We'll also be testing the features of the CAS, and we'll performing the use-based services provided defined by CORUS. Including procedural interface with ATC. And we will have, as I said, several different types of missions performed by the autonomous drone, by manned traffic, by eVTOLs. We will have nominal and off-nominal scenarios, and we will test air traffic rules as well to optimize airspace utilization and test critical KPIs for UAM, such as separation minima, minimum CNS infrastructure needed for UAM operations, and also other critical KPIs such as time to approve an UAM trip, for instance. And all of these flights and all of these tests will allow us to demonstrate automated UAM operations and also the dynamic change of operations due to unforeseen events. And of course, in general, the three demonstrations, the three flight campaigns, the one in UK, the one in the Netherlands, and the one in Santiago, They're going to allow us to test and implement the concept of operations that we're developing within AMU-LED, and see what are the things that we should implement and should go into the future. So this is the cue for the next presenter. We'll be performing the flights in summer next year, as I said before, and we will be preparing everything in the meantime. So thanks. I will be giving the floor to Alejandro now, which is going to present the CONOPS.
Thank you, Marta. So after these nice introductions to the project and the flight demonstrations, we are about to start our CONOPS discussion. I'm going to do so following the structure or the topics that you can see in. Let me remind you that you can use the Q&A panel to raise your questions at any time. Don't be shy. I'll be trying to assign them to our panelists on the best way I can for them to reply in real time in writing or orally during the roundtable at the end. So in that sense, apart from the speakers, we also have with us today as panelists our colleague AJ Mota from ANDRA, who will be kindly supporting us regarding regulation and standardization related questions. So also at the end of each of the presentations, we're planning to launch interactive polls with 2 or 3 questions for you to respond. Don't worry, it's not an exam to see if you were paying attention. It's just that, you know, we want your advice on some aspects to help us refine the concept. So I'm planning to make a first short introduction to our CONOPS, just to give you a bit of context before the rest of the presentations take place. But first, I'll start introducing myself. I am Alejandro Franzoy, and I work for the Aerospace Operational Efficiency and Autonomy Division with Research and Technology Europe, which is headquartered in Madrid, in case you wonder. And as Irene pointed out earlier, we are in charge of leading the elaboration of these CONOPS, which is, of course, a collaborative activity amongst all the. I should start by saying that there is an initial version of the CONOPS already available. We will publish it next week on Friday, most likely. But we will be distributing it amongst our advisory board members first. We will be sending it out today after the workshop. Wanted to serve, you know, some sort of introduction. There will be then 2 more updates, one in January next year, and third and final one at the end of the project in October, incorporating the lessons learned from the summer trials that Marta just introduced earlier. The CONOPS itself is meant to serve as the basis for the AMU-LED demonstrations, and it builds on extensive research on the state of the art, which is something that we conducted during the first month of the project, and which results will also be published soon in a separate deliverable. And in there we review, I think it was over 170 different international and European references, including other urban air mobility concepts of operations like the ones released by the FAA or Australia, or former SESARJU space exploratory and VLD projects, as well as existing ongoing regulation and standards. And in that sense, although the CONOPS nourishes from international references, it lays within the European context in a way that it follows the European regulation on drones and US space, as well as other aspects envisaged by CHORUS and the EASA concept of certified category. So it tries to build from these references, proposing as few changes as possible in order to accommodate urban air mobility. One last important remark that I wanted to make here in this slide is that these CONOPS targets what we call a transitional midterm, somewhere between 2025, 2030, where we think the first piloted air taxi operations will take place within a relatively mature US-based environment with certain services already deployed in cities. So again, continue with the context. And in order to characterize urban air mobility, we in the document, we looked into four main aspects that you can see here in the slide. First of them being the business cases that we should be considering. And here we find proper air mobility operations such as air taxi, shuttle, airport shuttle, or air ambulance, or cargo, which needs to coexist with other airborne services such as inspection or good delivery, surveillance, and law enforcement. So then we looked into the type of vehicles that would be supporting these use cases, and in that respect, these could be classified attending to the category, which is related to the operation that they're used for, whether it's open or specific or certified, and attending also to their performance, which relates to the traffic management aspect. And in this sense, we distinguish between what we call the high-performing vehicles, typically air taxis and big cargo drones, and standard performing vehicles like the ones for inspection or small parcel delivery. And such distinction is purely based on traffic management purposes, attending to differences on the demands and requirements on communication, navigation, or on surveillance performance, flight performance, altitude, speed, the required infrastructure, in case of vertiports, the required use-based services, and so on. The reason for making this distinction is that, remember, we're not yet in a fully integrated environment, so we still must guarantee safety for the high-performing vehicle, which might have people on board, without at the same time jeopardizing the proliferation of standard performing vehicles, which could not afford too restrictive requirements, like being equipped, for instance, with certain detect and avoid equipment. So in this way, we will be having high performing vehicles being managed in a different way that standard performing vehicles, but yet in a coordinated. You will see more of that in the next. At the bottom of the slide, you will see that, as I pointed out earlier, we have established 3 different time frames attending to different aspects, such as the complexity of the operations, the emerging actors and services, the existing or forecasted regulations and standards that would be in place, and where we would be moving from, let's say, segregated, low risk, low density operations towards integrated, more complex, high risk autonomous operations. So while the short term introduces the first use-based regulation, so we have new actors emerging like the Common Information Service and the US-based service providers, and we have the first U1 and partial U2 services deployed. It's not until the mid-term, 2025-ish, that we think we will start to see the first air taxi operations with similar automation levels that current helicopters today, departing from vertiports with dedicated CNS infrastructure and use-based services on a relatively more mature use-based environment with most of the U2 services deployed by then in cities. Then, of course, fully autonomous air taxi operations are envisaged for a longer term in a fully integrated fashion with other manned and unmanned traffic using collaborative interfaces, but that is out of the scope of AMU-LED. So we're centered into this midterm transitional scenario. And there is finally there are of course a series of challenges that must be overcome to make these a reality. I've just listed a few in this slide here. For instance, on the technological side, there are vehicle-related challenges such as the performance and the ability to fly in certain weather conditions, or the reliability, the fact for the environmental impact, or even the autonomy, as well as other traffic management related challenges, such as the need, for instance, for airspace structuring and the confliction services attending all sort of aircraft with heterogeneous flight and CNS performances, which, by the way, could be seriously affected by the existence of urban cannons in cities. And that is technology-wise, but market-wise, urban air mobility must prove also competitive and must provide a strong value proposition, and so completeness with other transport means, but we understand by multimodality. And so there will be challenges too on the location, operation, and the integration of infrastructure like vertiports, and on public acceptance regarding safety, noise, visual pollution, environmental effects, privacy, and so and last but by no means least, there are multiple challenges based on the available regulation and standards. And although there's been a lot of activity over the last years, resulting in the well-known 945, 947, and new space regulation, and different ASTM and UCAN standards, there's still a long journey ahead. And luckily, we have this kind of R&D activities which are helping us testing some of these regulations and elaborating new standards and regulations for the integration of urban air mobility operations as well. Just my last slide. As I commented earlier, we try to respect as much as possible the roles and responsibilities and the services given in use space regulation, but they obviously need to evolve somehow in order to incorporate urban air mobility. So still, we are proposing the same set of actors, but with extended responsibilities to cope with this traffic. So for instance, we can think that US space service provider might need to obtain a new certificate to manage these high-performance traffic, providing customized services for them, for their operations planning, for their strategic and tactical conflictions to access vertiports and manage of nominal operations. Similarly, the Common Information Service, aeronautical information and airspace restrictions have been tailored for these high-performing vehicles, and the same applies to coordination mechanisms with ANSPs. And even the national supervisory authority should establish a means to certify new UAM operators who will, in the end, hold an AOC and should develop the acceptable means of compliance for vertiport certification and for granting license for pilots in command. So, as you can see, all actors will be affected in one way. And on top of these changes to, let's say, the existing actors, there will be new ones, such as the UAM operator itself and also the vertiport operator, who will be in charge of the ground operations, safety and security, boarding, charging or refueling, and more importantly, providing vertiport information, such as the availability, to coordinate takeoff and landing procedures with the US space service provider. And in the same line of thought, and just to conclude, some services will need also adaptation to cope with this kind of traffic. For instance, I can think of the accuracy, latency, integrity, and the refresh rate of the tracking information could be more demanding, or the conformance monitoring thresholds for activating alerts could be different too. And as I already mentioned, there would be separate strategic and tactical deconfliction services for, that should be tailored for this type of high-performing traffic. So, in the end, multiple changes that will be needed to accommodate urban air mobility. And now that I told you our vision, which is subject to many comments and interpretations, and I thought you guys do so, we would like to gather your opinion on a couple of aspects. So maybe Rafaela, while you launch the poll, I would just say that the first of the aspects that we would like you to provide your view on is the responsibility of managing this traffic. So we proposed that there's a new kind of US space service provider with higher privileges that handles it, but you might have a different opinion. And also we would like to know what are, in your opinion, the main challenges in regulation. So if you should be able to see now a survey popping up. You will notice that for the second question, there is like a final option which says other, specify below, and then we allow for a third question which is blank for you to write any free text that you want there, in case you have a different opinion of what it's written on the options A to D. It's just the the workaround that we had to do in order to have this free text option available. I think Rafael is giving you like 3 minutes to complete the survey, and then we can comment on the results. So I will just be quiet so you guys can read through the. While you publish the results, or just to remind everyone that you can use a Q&A also to make your comments, and we can discuss those in the end if they are related also to these questions in the poll.
You have the results now, Alex.
Okay, I'll try to extend the panel. See what was the most popular. Okay, interesting. So there is a kind of a draw here. Green option. There are three options actually: B, C, and D. I mean, it's quite an open problem. We had many discussions internally. We're hoping to, also discuss this matter with other VLD projects, kind of share the same common approach. It's true that we all can have our own opinion. That's a good way of testing things too, especially on this, exploratory project. But yeah, good to see that. And regarding the second question on the regulatory part, so there is a winner here on new airspace rules, indeed. And just a minor comment here, we have a whole work package devoted to this, to looking for identifying potential gaps. So you keep an eye on our project, because we will be also touching on that, and we'll be making some more document available as we progress during the course of the project. So okay, I think I'm conscious of time. I think I'm gonna just pass the ball over to Victor, or maybe Rafael, you can do so, for him to introduce the airspace structure.
So, hello, good morning. My name is Victor Gordo, and as Alex has said, I'm going to talk about the proposed aerospace structure in the AMU-LED CONOPS on behalf of my company, Eneco, which is an Spanish engineering company focused on transport infrastructures, railways, roads, airports, and air navigation. I am an aeronautical engineer. I've been working in air navigation for more than 20 years. And in the last 5 years, I've been involved in several US space projects like Terra, Impetus, Domus, and now Dacus and AMU-LED. And well, let me show which is the aerospace structure we have proposed in this project and the reasons for that. First of all, to introduce this aerospace structure, we need to know that our main challenge is to provide a safe and effective integration of UAM operations. So to do that, we need to be able to provide safe separation and conflict avoidance problems. And we have three main challenges. The first one is the separation of drones with regard to manned aviation, specifically the high performance vehicles and VFR aviation. This is because general aviation commonly lacks of any kind of transponder or ubiquity means, or not all of them have them. This is a real problem for integration with unmanned vehicles. In general, with manned aviation, there is a different altitude references. Manned aviation has traditionally used barometric altitude, whereas drones use GNSS altitude. And this is also a problem which difficults the integration of these different traffics. Then, as Alex has mentioned before, another challenge is the separation of high performance vehicles and small drones. An air taxi, even a smaller taxi, or a large cargo delivery, or are going to be large vehicles with a high performance, high flight envelope, very different to small drones of less than a kilo or a few kilograms. I mean, so we have to cope with this problem also. We have the limited range of the existing drone remote AI identification solutions, which are currently based according to the, for example, ASTM standard in Bluetooth and Wi-Fi. This doesn't allow a long range, so it's not a solution to provide a full separation. We can talk about ADS-B, but we know that it cannot be generalized to every drone, in case we cannot saturate, or we don't want to saturate the 1090 band, 1090 megahertz band. And on top of that, we had that, as said, a small performance vehicle, a small UAS, and a high performance vehicle have different features and performances, speeds, cruise heights they can reach. So well, even maneuvering. So this is a problem, and they have to operate differently. And, and also, a small drone cannot afford the same onboard equipment that a vehicle, a costly vehicle, even an unmanned one can afford. So we need different solutions, or we are going to have different solutions. And finally, well, we can consider that US space can deconflict on real time and tactical. We can provide separation, but this tactical separation, the complexion is very complex. In traditional manned aviation, we have vehicles flying from one point to another, mainly along prefix routes. The separation is done by the airspace structure, and the conflicts are always in, I mean, crossing routes or parallel routes, but they are there are limited type of conflicts. In drones, we have different types of drones: fixed wing, multi-rotors, hybrid. We have different sizes, different maneuverability, and drones flying apparently to every place. So the tactical separation is much more complex than in manned aviation. And also we have an environment which is also much more complex, because in traditional aviation we have only an ATM provider in each volume of airspace, and here we are going to have several geospace service providers collaborating, which increases, of course, the complexity. So with all of that in mind, we have proposed an airspace structure which tries to handle all this problem and provide a compromise solution. Then we can see here on the top of the picture above BLL man aviation. Then we have two layers, one the high performance layer and the standard performance layer, mainly devoted to high performance vehicles and small drones. Let me explain the concept. Well, as said, the suggested airspace structure has two different layers which are within very low level. So being within a very low level, we can see that the high performance vehicle layer will be separated from manned aviation, solving therefore the problem of separation with general aviation without conspicuity, both also the problems of different altitude references. And then the high performance vehicle layer and the standard performance vehicle layer will provide a separation of large drones, air taxis, from these small drones, which are the most common ones nowadays. This provides separation between these two types of vehicles. We consider that this solution is a feasible way in the short to mid-term of providing environment of safe of operation of all these kind of vehicles without doing very dramatic changes in the current way of proceeding of manned aviation, and also allowing the continuing operation of small drones. But of course, there is one problem remaining, which is that the high performance vehicle layer is okay when they are in cruise phase, but they have to land and take off. Well, for that, we have considered that vertiports will be located in typeset airspace volumes. And when a drone, a high performance vehicle pretends to take off or land, they will activate some predefined dynamic corridors connecting these vertiports with the high performance layers. Why is the reason to have this corridor not all the time activated? Well, because we consider that otherwise we will be restricting too much the airspace for the small drones. So the idea is to, I mean, to use these volumes of airspace or to protect them when they are required to be protected, not the whole time. This is the idea behind. And this way we will assure the separation between the high performance vehicle and standard performance vehicle, even in the standard performance layer on the ground, let's say, where the vertiports will be located. So which will be the general way of working of this high vertiports? Well, they will be located in ZU airspace attending to chorus definition. So when a high performance vehicle wants to fly or to take off, wants to land or to take off, it will request the USSP this operation, and the USSP will activate the corridor, and on the standard performance operation in the corridor will be cancelled, a geofence will be provided, and all vehicles over the area will be required to change their position and go out of this corridor or land if required. But what happens when a corridor is in a CTR? Well, when we have these vertiports in a CTR, we have a different problem. The airspace is a set A airspace, again, attending to chorus definition. So in this case, the USSP cannot activate the dynamic corridor by itself. So the process will be the following. Again, the operator will ask the USSP to activate the corridor to land or take off. Then the USSP will ask for permission, for approval to the air navigation service provider responsible for that volume of airspace. Um, so in case there is a dynamic airspace reconfiguration, they will not allow this activation, or they will allow it not other aircraft, manned aircraft is operating at the moment. And then when the airspace is free from manned aviation, the ATM provider will allow the USP to activate the corridors, and the operation of UAM will take place. And then we assure also separation not only from of high performance vehicle from a standard performance vehicle, but also from manned aviation. And well, the last point I want to mention, and perhaps you have already gone through it, is that what happens with these larger taxis which are thought to fly in, let's say, larger, they have a very high flight envelope, higher cruise speed, cruise height, a larger speed, and range. Well, of course, they cannot fly perhaps in very low level or not all the time, because they have a greater visual and noise impact, and they have a higher flight envelope. They have to fly, for example, at 10,000 feet. What do we plan to do with them? Well, of course, for cruise activities, they will have to fly above very low level. So what our idea is in the short term to provide a limited number of corridors for this high performance vehicle. But considering that if you are going to fly from the airport to the city, you are going not to jump to 10,000 feet. And this happens when you are going to fly from one city to another at or from one place to another at 100 kilometers at least. If you are going to fly a few kilometers, you don't have to fly to 10,000 feet and then go down again. It doesn't make sense. So in case you want to fly to a larger distance, we can set a number of limited corridors, and the word limited is very important, because if we establish a unlimited number of corridors, in fact, what we are penalizing is manned aviation in general, extending very low level to 10,000 feet somehow. In the long term, perhaps flexible use of airspace, well, all high performance vehicle and VFR manned aviation can operate in a segregated environment, provided that in the long term all VFR flights will be properly equipped and we can assure separation. So just to end, let me recap. We have three different layers: above VLL, traditional manned aviation; in high performance layer, which will be a typeset airspace with high performance vehicle. Of course, man aviation could enter this airspace provided that they are equipped with the required onboard equipment, conspicuity means, whatever. And on the ground, a standard performance vehicle closer to the ground where they are not, I mean, they are not so noisy and they can fly closer to the ground at lower height speed, not interacting with the higher performance vehicle, but only in the time they want to take off or land. So we will have, in this case, dynamic corridors around vertiports. And the last point before closing my intervention is that, of course, we assume that between a BLL and man aviation, there will have to be some kind of safety buffer, which is to be defined. It's not yet in our concept, but we have to define a safety buffer. In a lot of states currently, the drone operations can only happen to 400 feet, not to 500 feet. So yes, we assume that there will be required a safety buffer, and also a small safety buffer between the high performance layer and the standard performance layer. And well, this is in summary what we have planned for the aerospace structure. We know that is perhaps a challenging aerospace structure, but we think that it allows a different way of proceeding and not a large impact in man aviation in the short term. And well, to consider this, we are going to show a poll. You can answer. Rafaela is going to show a poll. Well, you can we can already see this poll in the presentation. So we have three main questions. The first one is related to the main advantages of the proposed aerospace structure, and you can choose several options. Then you can also provide a new answer, perhaps if there is an option which has not been provided. The second question is related, number 3 is related to the disadvantages of this proposed aerospace structure, also with different options you can choose, more than one, and also an option for a different option we have not proposed. And finally, with regard to the safety layers, safety buffers I have already described, which is, in your opinion, which should be the well, the height of these safety buffers? So please provide your answers. Thank you very much for your attention. So I think the poll is closed, isn't it, Rafaela? Can we see the
Yes,
results?
the results are visible in just a few seconds.
Thank you, thank you.
And here we go. Ready
Okay.
for you.
Okay, thank you very much. Very interesting results indeed. We have 40 people that says that the main advantages of the proposed aerospace structure are relating to providing separation with man aviation without recovering any space chain, and also the dynamic of activation of protection volumes around the vertiports is something that 35 people consider very interesting. And also the allowing more flexible UAM routes. With regard to the disadvantages, the most selected option is the problem with safety buffers. Yes, that we also consider that could be something to address. But also the high performance layers cover wider volumes than corridors, and preventing air taxis from their optimal cruise height. And finally, well, we have different replies with regard to the minimum height, but we can see that most of them consider that at least 50 feet will be required, which could be, of course, a constraint. And well, this is all from my side. Thank you very much. And now we give the floor to our colleague Gokan from Cranfield.
Hello, Victor. Thank you very much. Thank you very much. So yeah, this is Gökhan Elhan, BA System Chair, Professor of Autonomous Systems and Artificial Intelligence here in Cranfield University. And specifically, what we're going to touch today is the separation and conflict management that we envision under the AMU-LED project. And how we see this thing, that this whole composite CSM thing is obviously the separation and the way that you see it, rather this be through these actually layers, rather this be at the high performance vehicle side or the standard performance vehicle side, and this airspace structuring that we have, including type X, Y, Z, and granularities between Z, and very much leading into with procedures into procedural separation, and that's what we see as the main separation guideline. And of course, above that is, or integrated or interwoven into that, is this notion of conflict management. And this conflict management, as you probably all know, is happening at different time scales, starting from strategic level, going into tactical, and then actually into metal to metal or real-time situations, you're going into collision avoidance, rather this be detect and avoid or see and avoid of the set. And one important aspect is this actually, this how you do this and the granularity associated with it is also kind of like dependent on the types of the vehicles. So it's actually, I'll be very open, it's a learning game for us too, because the notion that you get out of an urban air mobility or an advanced air mobility, rather this be a standard performance, unmanned air vehicle or a higher performance aircraft, which could indeed be autonomous as well, not only manned and autonomous. And manned does not necessarily mean that it's not autonomous. So, and the level of autonomy is interesting down here. So it adds in different types of flavors to all of this question. And it's a question that we cannot answer its whole in its full entity, but we're taking slice by slice, piece by piece. So this is the first cut that we have towards this. So moving into it, it's important to identify the actors involved, rather this be competent authorities, rather this be the USSPs, rather this be the Common Information Surface and the support of that, or the operators, pilot in command, and in control, and the kind of like the activities that they take under as a part of separation and conflict management. And within this integrated structure, we started with airspace structuring, but we're also looking at operational planning, ground level surveillances, geographical containment, and methods for detect and avoid. And as you can see, all of these are happening on kind of like different time scales with priorities, with sporting actors having a touch at different points. We kind of try to reflect it less. Again, this is this line of thinking would probably resonate with quite a number of people down here with an approach similar to the one that has happened through the FAA and NASA, and it's looking at the timeline, looking at the parties responsible and what they're doing with regards to different types of aircraft within this whole structure, rather this be the high performance traffic, manned aviation, standard performance traffic, and others. And other things include things like terrain, obstacles, hazardous meteorological condition, airborne hazards that is very, very much common to both urban and indeed semi-urban and rural areas. And if you can go through this, as you can see, the progression is happening from, a regulative side, a structuring side, all the way down to real-time collision avoidance, detect and avoid, and see and avoid. And we kind of like compartmentalized with regards to each one of these actually responsible parties. And the fundamental question becomes is with such a complex scenario is, how do you test algorithm? How do you test methods and so on and so forth? Towards this one of these key challenges, and we were kind of like aware of this from day one while we were preparing the proposal itself, the AMU-LED proposal itself. And the issue was to sit down and understand both the methodologies, rather this be from an airspace structuring level, and also the actual implementation of the procedures, going all the way down to detect and avoid or see and avoid. We would need to kind of like test it out and kind of like understand it from an exhaustive sense. And this is one of the efforts that we are currently focused in, is to be able to do this within a simulated environment, which can embed in both manned flights, unmanned flights, vertical takeoff and landing vehicles, rather this be manned or autonomous, embedded into specific simulation scenarios. And within down here, you're seeing a highlight of this actually, this whole modular structure that we are progressively have and progressively building within Cranfield University to look at separation and conflict management. And one of the interesting features of this is the inherent capability that we're building inside it to be able to do co-simulation and co-testing with live flight tests. So that extra number of vehicles, extra number of risks that come having from a large number of volume of vehicles is kind of like to some degree evaded by having some virtual elements as well within our flight testing scenarios. And here, of course, the immediate issue that comes in is the nominal cases. And of course, within down here, you also see you kind of like sense the off nominal cases, but what's happening at the contingency management side, meaning that, off nominal cases, you're looking at contingency management, and there is actually further situation of actually further level of that, which is pretty much emergency management in emergency situations. And what we are getting, especially with regards to all of these urban environments, including unmanned air vehicles and manned air vehicles, and some of which might have some autonomous or semi-autonomous features, is you're getting different notions of failures. Rather it be standard CNS failures that is happening in, or environmental effects that is happening from the very fact that you're operating the hydrodynamic blanketing effects, the effects that you get from skyscrapers and the other buildings, adverse weather effects, which can be local phenomena, and electromagnetic interferences. We pretty much that could be pretty much distributed across the whole urban operations that you might have. And we could indeed have human and operational events, including, very much piloting control, command, distractions, medical issues, and real-time obstacle collisions that might happen. And you might see all of these actually as appearing in because of a new construction appearing. A new crane comes in within the whole scenario, and it changes. And our actually look at it is looking at was also focusing on the possible contingencies that you might have from an urban air mobility perspective too. And these ones are also reflected to some degree in our approach, where we're trying to understand these and kind of like come up with a methodological ways of doing that. And one of the things that you see is this, of course, this emergency landing situations, where you're actually again looking at it both at a strategic time frame, a tactical time frame, and a real-time time frame, where you're looking at actually in the case of emergency situations, identifying locations to land, predetermined, not available, real-time determined, updating your geographical information systems, and so on and so forth. So it's a part of a whole cycle of events that you're seeing this. And we see this as a very key enabling method in both social acceptability and as a part of actually safe operations, as a case of safety cases to be able to do these types of things. And we are working towards implementing these within both simulation first, and then to be able to do it in the first flight test as a part of the technology development aspects. Which takes us into various research teams and kind of like the idea. So within obviously AMU-LED is a very large demonstration project. And at the end of the day, the success is driven by the very need to be able to sit down and demonstrate these capabilities, the basic fundamental ideas that we're developing at that time. But also there are also some key aspects that come from just the structuring of the business, right? Having multiple USSPs on the same airspace, okay? How do we do the capacity management? Do we do it in a centralized fashion or a decentralized fashion? Okay, so once that comes in, how is the CSM duties? How do you distribute this? Okay, where you have multiple operators taking at the same time, multiple USSPs at the same time, and we're actually looking at different methods and approaches towards developing, especially our AI-driven methodologies, to be able to do this in different type of architectural schemes, whether this be centralized or decentralized for dynamic capacity management and CSM. Also, one of the issues that come in is very much the nature of the business, that comes in, based on the operations that you have, geographical zone, geofences that appear, emergency landing sites, airspace structures, and dynamic airspace configurations. These are all parts of the kind of the current research that we're trying to embed into at least the simulated part of the experiments that we are going to have. So which brings us to the Rafaela, to the poll. So yes, and so let's go into the poll questions, and let me, Rafaela, if we could go into it. So we got two poll questions. Just a brief insight. The first one is with regards to strategic deconfliction. You know, do you think a mandatory tactical deconfliction service rather than advisory service will be needed? You know, especially within the high performing player if a pilot is on board. So one of them is that. The second one is, what is your opinion, the most important aspects that should be covered when developing standard contingency procedures? So okay. Well, so the first one, let me just open this up, okay, just to be on the safe side. So it's actually pretty much actually um, no- n- not surprising. We see with regards to strategic deconfliction, we're seeing actually human kind of like a evenly divided kind of like a the focus the focus down in here is more geared towards an automated USSP like service. Still provide a deconfliction command, so that is the attitude and heading and so on and so forth. Okay, that's interesting to have an automated USSP like service, even if pilot is on board. And the second one is the important aspects when aspects. It's actually a little bit evenly divided. So we're looking at location of pre-established emergency landing site, condition alerts, and the permissions of granting a little bit more in the permission of granting of permissions to change route and exit volumes. Okay, very nice. Again, thank you very much to all the participants for feedback on this one. Now I will pass the ball to Raquel.
Thank you, Gökhan. Okay. I'm Raquel Moldes. I work for ENAIRE's Drones Business Development Department, and I'm going to present some highlights regarding the AMU-LED proposals for integration with ATM and manned aviation. For the short term, as Victor has already explained, we are proposing to separate the manned aviation from high performance vehicles and standard performance vehicles, and to design the recently published US space regulatory framework will be applicable, and that means that in controlled US space aerospace, it will be the ANSPs, the one ensuring the segregation from manned aviation and the US space traffic. And for those manned aviation flying in US space and not receiving ATC service, they should make themselves electronically conspicuous. The reality is that the operations of manned traffic in urban environments is very limited, usually reserved for state operations and emergencies. However, these operations are still taking place in the urban environments, and we have to ensure the safety of these operations. To this end, and also because most of these flights are flying according to visual flight rules, and they are not receiving separation services from ATC, we are proposing some recommendations from AMU-LED. For the short term, one of our first recommendations could be that manned aviation should receive high performance vehicles and standard performance vehicles traffic information. This could be either because this manned aviation adheres to USSP services receiving this traffic information, or because this UAS traffic information is included as part of the Common Information Service, and in such way it could be provided by the ANSP through the Flight Information Service. The other recommendation is the need to use common UAM rules for standard performance vehicles, high performance vehicles, and conventional manned aviation. This would improve the awareness of the pilots and allow for a collaborative conflict avoidance. For the long term, and as the number of UAS operations in urban environments increases, we could advocate for a further integration of manned aviation and US space. To this end, we could recommend the manned aviation flying in US space in urban environments to adhere to the US space services so that they can receive also strategic and dynamic deconfliction services. Also, for the high performance layer, we propose to reserve this layer only for those manned aviation which is compliant with the high performance layer procedures and requirements, and also receiving those services which are mandatory for this high performance layer. Another aspect to take into account is that many urban environments are highly within the CTR of the airports. To this end, we have take the recommendation from the ACI concept of operations, where they propose 3 different drive fronts depending on the risk of drones flights for the other airspace users. Based on this approach, and in order to streamline the operations in urban environments highly affected by the airport CTR, we are proposing 3 different UAS operation categories: high-risk operations, which will need coordination with ATC and for which collaborative interface with ATC should be mandatory. Mid-risk operations, where ATC should be informed where an operation is taking place, but they don't require ATC approval. And low-risk operations, which are with a necessary distance to ensure safety of manned aviation operations, so they do not require any coordination with ATC. Finally, and as it has already been introduced by Victor, there might be vertiports within the CTRs of the airport, or even inside the airport. To this end, we are proposing 2 different ways to manage the corridors connecting the vertiport to the high performance layer. When these vertiports are far away enough from the airport as to ensure safety of the operations, they could be defined as U-space airspace, as they are considered low-risk operations. And for those which do not meet this condition, then the ATS provider of the airport should provide the activation and deactivation of these corridors, managing dynamically these corridors. Now we have prepared also some questions and polls to check your view of these proposals. Okay, the first one, makes reference to the recommendations of the high performance layer. And the second one to the additional recommendations to enhance the rules already established by the US Space Regulatory Framework. Okay, I see most of you advocates for full integration. That's good. It's what AMU-LED CONOPS are proposing, so we are aligned. Yes, most of you have deemed that the two recommendations will improve the awareness and predictability. So it seems that our proposal from CONOPS has more or less covered your worries for UAM. So we can close this section of the presentation.
Thank you, Raquel, for the presentation, and thank you everyone for participating to the polls. I've seen that apparently there was one poll that we didn't allow much time for you guys to respond, so maybe we can repeat that, Rafael. I think it was Gokhan, so I think that is number 3, poll number 3.
Yes. Apologies about that. I will reopen this poll now, and I'm allowing everyone 5 minutes to respond to it. Apologies, Alex, your audio is breaking a bit to me. I just let you know that the poll is closing now, and the results visible in just a few seconds.
Okay, thank you, Rafael. I hope you can hear me better now. So Gokhan, over to you to comment on the results.
Yes, got it. And I'm just waiting for Fela. Okay, just a second. Let's open this up. Just kind of understand the results one more time. So yeah, and okay, the poll changed. The results did not change. So they're increasing the numbers. The first one with regards to was that okay, if I'm reading this right. The notion is more of an automated USSP-like service for deconfliction comments, for even high performing layer vehicle with a human pilot on board. So, and the main thought process is towards such an automated USSP-like service. And with regards to the most important aspects when developing standard contingency procedures was kind of like evenly divided. I mean, if you ask me, I mean, there is of course that thing jumps up is the granting of permission to change route and exit volume to manage contingency if needed. But you also see actually quite a bit of opinion both on location of pre-established emerging landing sites and parachute deployment sites and conditions to alert, and kind of like quite evenly divided. But I should be kind of like I'm a little surprised for, especially at the high performing layer with a pilot on board, seeing an automated USSP like service for deconfliction comments, you know, and that's really interesting to note. So thank you for everyone who took part within the polling. Thank you.
Thank you, Gökhan. I think there is time left, Rafaela, for to bring another poll. This time it's regarding a topic that also created some debate internally in the project, which is the management of vertiports. It's just there are 3 questions there that you have a look at and provide your views on it. So thank you, Rafaela, for launching it. We have 5 minutes to complete the survey, and then we will move straight away to the questions and answers.
Alex, results are ready.
Okay, thank you, Rafaela. I can see those. So it's just, you know, I can move the panel, extend it a bit further, or I can remember the question. Right, so the first one had to do with the management or the vertiports, and also the winner seems to be that it is the US space service provider who provides clearance, which is an obvious as well. It's a good understanding that we were sharing here internally as well. But it has to consult the vertiport operator for the availability of the vertiport and the potential presence of obstacles. So this seems to be the approach that we were looking for in our econops as well. There were other ways of looking into this in literature that we found, like it could be the vertiport operator itself who could provide clearance, but we are also in favor of option C as you guys are suggesting here. Right, what happens if the vertiport it's within an airport environment? Most of you have gone for the first option, which is that ATC should be ultimately responsible for corridor activation, attending, of course, to the demands from the commercial aviation. That is one of the proposals we are including in the CONOS as well. So it's good to see that you're in line with news. And lastly, regarding this service for vertiport management, whether it should be or not integrated, also seem to go for the last option, which is indeed making it an input for the strategic deconfliction and dynamic capacity management. So it's good to see we're all aligned. Happy to see that. We reached the end of the workshop, so there is no much time for more. We had another poll ready regarding the weather service, but we're going to skip that. In the sake of having more time to reply to your questions, we tried to do so on the best way we could in writing. I reckon I struggle to catch up and follow all the questions that we have received, because I can see we received like 36 different questions. So I've been trying to assign those to our speakers, and we've been providing answers in writing, but we still would like to elaborate on a few of them that I picked up are potentially important, that could open a debate, that there's being a repetition of questions around those topics. So I'd like to start by Marta. There was one question from Ansgar, which I put in the prioritized panel, and regarding the challenges on vertiports. Can you see that? Do you want me to read it to you?
I see it. Maybe I'll read it first so that everyone knows what are we referring to.
Yeah, good.
So the question is, I consider one of the key challenges to be the availability of full service vertiports. Finding spaces for them in congested urban centers will be a challenge and thus expensive. Have you factored the infrastructure costs into the business cases? So we already replied to this answer to this question, but for it is a very interesting question. So we're going to elaborate a little bit further. And indeed, vertiports, I think vertiports are a challenge of their own. You have to look at the optimization of their location within the city, the energy requirements, but even you have to look at the design of the vertiport so that it is embedded within the landscape of the city. So these are things that have to be looking at and are definitely something important. But in AMU-LED, we are more focused on the regulatory, technical, and airspace aspects that are more needed for enabling urban air mobility through use space. So when looking at the business cases that we mentioned before, um, we use them more as part of the storytelling of our demonstrations, because our demonstrations are mainly going to be demonstration of the technical aspects of the CNS systems, of the airspace structuring, these kind of things of our conserve operations. So the business cases, so an air taxi, cargo delivery, um, inspection, these kind of things, they're the storytelling. They're part of the story that we want to tell when we're demonstrating. So that is a holistic approach, but we're not actually going to look at the economics of the business cases, but rather just the technical aspects of use space for urban air mobility. I hope that answered the question a little bit more.
Thank you so much, Marta.
Yeah.
Let me pick up on another question. Can I make this smaller? Oh, no. Yeah, so Victor, I have one for you here. It's coming from our friend Miguel Aguilera. It says, will the CONOPS make concrete suggestions, proposals about CNS services for UAM operation? Looking forward to reading the CONOPS. Can you reply to that, Victor?
Yes, yes, I can. Well, Miguel has asked a number of very good questions regarding CNS performances. Yes, in fact, well, our view is that small drones cannot be as well equipped as large UAM vehicles, but also they are going to fly in well, open or specific standard scenarios in not very challenging operations, BLOS, EVLOS, or limited BVLOS in any case. So yes, we consider that small drones will have navigation based on GNSS, but well, considering current state of the art, no or not generalized kind of integrity monitoring. That's why they will be limited to some not very challenging operation, and this is really what they are asking for. On the contrary, large vehicles will need to fly at higher speeds um, in more challenging operation, long distance BVLOS, and in this case they will be required to have um, greater redundancy, integrity monitoring on GNSS receiver, better GNSS receivers, also more robust cellular communication, even perhaps SATCOM in some cases, or duplicated um, service providers, depend on the necessities. But yes, we have provided the requirements based on the kind of operation they plan to develop and on the challenges, and also considering what they can afford. I mean, we can also ask a small drone to have great equipment. But well, let's see the CONOPS, and of course we will be pleased to discuss this with you.
Thank you, Victor. Pick up the next question. I have one here for Gokhan. It's coming from Andrew Bentley, and it says the following: the manned aviation in high-performing layer. Can you see that, Gokhan? Maybe you can read it out loud.
Yes, and the question is actually, and Andrew, excellent question. That's where the can of worms start opening up, right? And then the question becomes it at a high performance HPV layer, okay, which basically involves high performance vehicles, rather this be manned and unmanned vehicles, and some manned could be potentially autonomous, right? They could be just passengers. And Andrew's question was like, yeah, but the major source of errors, especially would come from not machine response but human response, okay, especially with regards to collision avoidance and how to factor in, would that be the so I read the question a little bit more. Maybe Andrew asks very something simple, but I read the question a little bit more is how would that complexify the whole actually, the collision avoidance schemes? Yes, and it does actually, Andrew. And that's actually, I wish I would say that I had the answer, the golden egg to that question, but it still is. But what I would see is actually this machine to machine, that first advisory, and then actually guidance comments, and then the last, metal to metal crash situation where you have an automated maneuver happening in. I would say that would be appearing more on the autonomous vehicle side. But that autonomous vehicle side would involve, especially, would need to kind of like take into account the potential blunders, that could appear from the human high performance vehicle that is happening at the same time. Of course, the complexifying factor is actually that autonomous vehicle, once doing it, might have humans on board. That puts in limitations on the maneuvers and so on and so forth. But again, very open area, and it's actually an active research area how to be able to do that. So thank you for this.
Thank you so much, Gokhan. I think there is time for just one last question. AJ, I would be addressing that to you, if that is okay. It's coming from Richard Ryan on the intended roles and responsibility of the different stakeholders. Can you take that?
Yes, Alex. Oh, hi. I suppose you didn't hear from me during the presentations, but my name is AJ Moda from Andrew Technologies, and I'm supporting all of the work that all these fine folk are doing on AMU-LED, but specifically around regulations and standards. So just to repeat the question, how do you intend to extract roles and responsibilities of all stakeholders in order to inform the regulator as part of this project? And part two of the question is, how will priority of flight be established so as to provide equity to all airspace users? I think we tackle the first one around roles and responsibilities. Within the AMU-LED project, obviously work package 7 is focused all around on regulations and standards. And one of the key to AMU-LED is around bridging the gap between what is considered developmental today, so emerging standards, emerging regulations, and how to operationalize them and de-risk some of these things. So our starting point for the project is on roles, where we define what UTM service providers do, what ANSPs do. And then through building up the technical solution and demonstrations is a case of learning and evolving those roles. But ultimately within Work Package 7, there is a body of work that will be focused on engaging both with the regulatory bodies, so EASA in this case, but also the national aviation authorities in the UK, Netherlands, and Spain. And slightly separately also engaging with the standards bodies, both ASTM and EuroK, to ensure that the roles and responsibilities that are being defined in standards have got feedback from projects such as these so that they can build on that work. That's the first part. Alex, if I've got 30 seconds, I'll try and answer the second one, which is priority of flight be established.
Okay, just no more than 30 seconds.
No more than 30 seconds. Okay, well, This is a really difficult question. It always comes up again and again because of the issues around commercial operations versus all of the other types that we get. Our view is you have to start with, based on the layers, that you start with best equipped, but also first come, first serve, and you just try and balance those two, and we will learn along the way. Back to you.
Thank you so much, AJ. I'd just like to, quickly wrap up because we're 1 minute over the hour. Thank you so much for your participation. You can see this is the very early stage in the project, which is, kind of got together to think of these concept operations that we introduced today. We expect many changes. We would very much appreciate it if you can send us your comments. We will be distributing the document itself amongst our advisory board members today. So comments are more than welcome. We will incorporate them to next versions of the ops. And since the document will be also public, anybody is welcome to provide comments to the document and send those to us. So we can take those into account for not just for the updating the newspaper, but also for the control operations and the trials that we are planning for next year. Having said that, we're planning to make a video of today's session available, and also we'll be sending the slides. And on top of that, I'm thinking it would be good to include some sort of workshop report where we can include all these questions that we have received today, because I could see that a lot of them could not be answered in time. So maybe we can sit down and reply to those and provide you with the report within, let's say, a couple of weeks' time. So that's all from my side, and on the AMU-LED team, again, we'd like to thank you so much for your participation today. That's all. Have a good day and have a great weekend.